Welcome back to my course Formal Methods for System Verification. In today's class, we will learn the various optimizations that you can apply over Tseitin transformation. Just to recap, what is Tseitin transformation? Given any arbitrary propositional formula, if you want to convert into CNF formula, if you apply Tseitin transformation, you will always get a formula which is of linear size, right? So, this I have discussed in the previous class. Just to recap, what was the process? You effectively have say some arbitrary formula like this. I will construct the AST of that abstract syntax tree, and then for each operator I will introduce a new variable. So, this is the implication, this is the and then I will write effectively 3 clauses, right. So, I will write clause C1, which is represent this one, which is A1 by implication X1 implication A2, right. So, this represent this one, then clause 2 which represent this part of the formula, which is A2 by implication X2 and X3, right. So, and then I have the clause which represent A1, and then we have shown that if I convert this formula logically, I will get CNF. If I convert this formula into CNF, it will always I will get CNF, and this will always result in 3 clauses, this will result in 3 clauses. So, overall I will get 7 clauses, right, and I have shown that in detail in the previous class. Just to completeness, for this formula, this is the formula in CNF I will get, right. This part is for the clause 1, this part is for the clause 2, and this is the clause 3. So, this have 3 clauses, one clause is this is the second clause, this is the third clause, and this is clause 1, this is clause 2 and clause 3. So, there are 7 clauses, right. So, this conversion we have learned in the previous class. So, we also have shown in the previous class that this conversion generates equisatisfiable formula, not equivalent formula, right, and we have already discussed what is equisatisfiable and which is equivalent. So, just to recap that also, equisatisfiable means that if this formula is true or satisfiable, this formula is also satisfiable, and does not mean that they are satisfiable under same interpretation, right. On the other hand, equivalent, they are satisfiable under all interpretation. If this formula is satisfiable, this is also satisfiable, right. That means for some interpretation, if this formula is also true, this will also be true, right. But for equisatisfiable, that is not necessary. This may be satisfiable under some interpretation I, and this formula will be satisfiable under another interpretation some I1. Okay. So, I will basically show now this Tseitin transformation will not create an equivalent formula, right. Let us take my formula is P or not P. So, this formula is satisfiable definitely for every possible value, this is true. So, this is also valid as well, right, because if you give P equal to true, this will be true, and if you give P equal to false, then not P will be true. So, this formula is always true. Now, if I do the Tseitin transformation for this formula, so what I will basically create a graph like this, right. So, I will have OR P and not P, right. So, this is the, and then I will create some A1 and write A1 by implication, or say in my example I have taken X by implication P or not P, right. And then if I convert using that rule, so I will get not X P or not P1, X not P and X or P. So, this is the formula I will get through from this, right. So, which I have explained enough in the previous class. Now, say this formula is always valid. So, this is also satisfiable. Now, if I can also show that this is also satisfiable, why? So, if say I take some value, let us say P equal to true, right, and X equal to true. So, under this is true because P is true, X is true, X is true. So, this is true, this is true, this is true. So, this is satisfiable. So, this, if the original formula is satisfiable, this is also satisfiable. So, equisatisfiable zone. Now, let us say I have taken P equal to false and X is also false. So, P is false means and X is false. So, what will happen? X is false, P is also false. So, this will become false, right. So, and then the entire CNA formula will be false. So, the entire formula is false. So, this is not valid, right. So, that means they are not equivalent. So, there is one interpretation under which this formula is false, but the original formula is true for all interpretation. So, this effectively shows that Tseitin transformation won't generate an equivalent formula in CNN. Okay. But the primary objective of today's class to show you what is the further optimization I can do over the normal Tseitin transformation. Okay. So, the first optimization says that in general what we do, we write a clause like A1 by implication whatever the x1, x2. So, this is the general kind of clause that we add for each operator, right, in the Tseitin transformation. What this optimization says that if I just add A1 implication x1 star x2, that is also fine, because this will also keep the equisatisfiability property true, because if this is true, I have to just assign true to it, right, and if this is false, I can assign true, false, anything. So, I will always get an satisfiable assignment for the CNF formula, right. So, that is why because my primary focus is to get the equisatisfiable formula, I do not need by implication here, I can just use implication. So, that will reduce the term from 3 to 2 some cases, right. So, this is what I say, that this is not needed actually, right. If you have by implication, it means that this and this, but this is sufficient. Okay. Next is optimization 2, in which we basically say that if you have a conjunction of literal with a conjunction of literal in the original formula, I can use only single variable, I do not need multiple auxiliary variables. Okay. So, for that, let us say I have a formula like this. Okay. So, here in this case, this is a conjunction of literals with AND, but this is still not in CNF, right, because it has all this should be in other way, this is actually in DNF, right. So, if I construct the AST for this, I will get OR x1, then AND, then x2 and x3, then AND x4, x5, right. This is the things I will get. In normal way, I will add a auxiliary variable like A2, A3, A4, right. So, this is the normal way. So, what these are saying that you do not need A2, A3 and A4, you just keep A2 and this is not needed, this is not needed. So, then also the formula will remain CNF. So, as long as you can generate a formula which is CNF, this is fine, right. So, that is what say. So, but I have to show that without this A3 and A4, the formula is still CNF, right. So, that I will show you in the example. So, in the normal one, as I mentioned, so if I have this is the formula, I will get one clause which is I will get A1 by implication x1 or A2, right. This is corresponding to this variable. Then I will get A2 by implication x2 and A3, right. Then for A3 I will get similarly x2, sorry, this is okay. So, this is x2, x3, x3 and A4, right, and similarly I will get one for A4, I will get A4 by implication x4 and x5. So, these are the clauses I will get, and then if I convert them into CNF, I will get the corresponding form, right. So, for C1 I will get this, for C2 I will get this. There are two clauses, as I mentioned that I do not need the by implication now, right. So, I just keep implication here and I will get one clause here, from this I will get two clauses, from C3 I will get two clauses, from C4 I will get two clauses. So, overall clause I will get 2 plus 2, 2 plus 2 plus 2 plus 1, right, 7 plus the original one, right. So, you have to also add a clause A1 into this. So, overall I will get 8 clauses here, right, and original formula has 5 variables and I have introduced 1, 2, 3, 4 new variables. So, 5 plus 4 you have 9 variables overall. So, this is the formula I will get in original way, and also I have replaced this by implication with implication. I have already applied my optimization 1, otherwise I would have been I would get 3 into 4, right. So, 12 plus 1, 13 clauses, right. So, for each such case I will get 3 clauses plus the original clause 13, but with the optimization 1 I effectively get 8 clauses. So, already 5 clauses has been removed because of this optimization 1. Now, if I take the same formula, let me draw the construction, the graph again. So, I will get x1, then x2, then x3, x4 and x5. What I am saying now, my optimization 2 I will use a1 and a2, that is sufficient, okay, and still the formula will be in CNF. Then what clauses I will get? I will get a1, the clause 1, then I will get a1 implies x1 or a2, right. So, this is my C1, this is C2, which is equivalent to not a1 or x1 or a2. So, this is the clause I will get from this. Then C3 is basically for this C3, which is a2 implication. I will just write x2 and x3 and x4 and x5. So, that was the original expression, right. Now, if I write this, this is not of a2 or this x2 and x3 and x4 and x5, right, which is equivalent to, I have to distribute it, right. So, not of a2 or x2 and not of a2 or x3 and not of a2 or x4, right, and not of a2 or x5. So, these are the 3 clauses I get, and these are all CNF, right, because this is disjunction of literal and conjunction of these clauses, right. So, overall clauses how many got? 1, 2, 3, 4 plus 1 5 plus 1 6. So, I get 6 clauses and new variables is 2. So, 5 plus 2 7 variables. Earlier I got 8 clauses 9 variables. So, I have reduced 2 clauses 2 variables, right. So, this is the optimization 2. So, this is what explained here in detail. So, this is the clause I will get, and then if I write them I will already explain the formula I will get, right. So, in general it will reduce. In the optimized encoding I will only have new variable for the entire conjunction of n literals. I will effectively get n minus 1 clauses, because if you see the pattern here, what I am doing, whatever this x2, x3, x4 I will get like not of a2, x3, x2, not of a2, x3, not of a2, x4 and not of a2 and x5, right. So, if the original formula has entire and get has n number of such literal, I will get n minus 1 clauses, right. So, if n an operator, right. So, you have n minus 1 variables say there, okay. So, I will initially I will get 2n clauses, now I will get n minus 1 clauses, right. So, this is what the conjunction, right. So, what I am trying to say that x1 and x2 and x3 and say xn, right, this is what I have say. Then effectively if there are n clauses I will get n clauses, because I will have say a1 implies this. So, then resultant will be not a1 or x1 and not of a1 or x2 so on, and then not of a1 or xn. So, I will get n clauses effectively, but in the original world I will get roughly 2n clauses, right. So, here the explanation is given in terms of n minus 1 variable, but if you take n I will get n clauses, here it is kind of 2n clauses. So, almost the clause size will become half if I apply optimization 2, okay. And then the third optimization says that if your formula, if you convert into NNF first and then apply Tseitin transformation, this will reduce further size of the formula, okay. So, for example, let us take a formula, this is not in NNF, right, because you have negation which is not part of the literals. If I convert the formula into NNF, what will happen? This negation will be always with the atoms or the propositional constant. So, let us take this formula and I will show a detail. So, if this is the AST of this corresponding to this formula, because this is x or not of y or and of Z and W. So, this is clear, right. So, then what I will do, I will basically assign A1, A2, A3 and A4, right. So, new variables, this is what I am going to assign, and then I will write for every new variable a clause like this. So, I will have A1, then A1 implies X or A2, X or A2, this is the part I am writing. Then I will write A2 equal to not of A3, not of A3, this is for this operator. So, this one is A3 implies Y or A4, right, this is what I will get, and for this one I will get A4 implies Z and W, right. So, this is what I will get, and then I can easily write their equivalent version, which is, say, for this case it is not of A1 or X or A2. This is already disjunction literal, this will come, no, not this. So, this is not A2 or not A3. So, this is also CNF. For this one, not of A3 or Y or A4. So, this is the clause I will get, and from this not of A4 or Z or W, right. So, this is the clause I will get. So, this detail I have shown here. So, these are the things I will get. Okay. So, I will get, these are the clauses if I convert, right. So, effectively I will get 6 clauses, 8 variables. Okay. Now, if I say that if I convert this into NNF, this is my NNF form. You see this, this negation is now with De Morgan's law goes inside. So, this is my NNF, and the corresponding est is this. So, this X or of this and then not of Y or and of this, right. So, this is I think W, right. This is what the est I will get, and then I will use A1, A2 and A3, right. And then I will write the clause A1, then A1 implies X or A2, then A2 implies not of Y or A3, and then A3 implies not of Z and not of W, right. So, with this if I convert, so I will use 3 new variables, and then I will get these clauses that I have already explained, and if you convert them I will get these clauses, right. I mean, you can actually do it your own, and then I will get 5 clauses, 7 variables. So, earlier what I got 6 clauses and 8 variables. So, now I am getting 5 clauses, 7 variables. So, I am able to reduce 1 clause, right. So, this effectively shows that if I just convert into NNF and then I do the Tseitin transformation, it will reduce the size of the est effectively. If you see here, this not was creating a new node here, right. So, not was creating a new node and the depth of the tree is 4, right. On the other hand, if I do the negation, the not is coming inside the literals, right, and here the length of the tree is become 3 now. So, the height reduce, new variable reduce, number of clause will reduce, right, for because every new node will have at least 1 or 2 new clause will come, right. So, this is how this optimization 3 will help you to reduce the size of the formula, right. So, what we have learned so far is that we have learned this Tseitin transformation to convert any arbitrary formula into CNF, and the kind of steps is like you first convert into NNF, then you identify the entire auxiliary tree entry, and then you use only one variable for that instead of normal variable, and then you create this equisatisfiable clauses with this implication only, not by implication, and then you create the CNF formula and then combine the clauses. So, this is the actual steps you should follow in Tseitin transformation, which take care of all 3 optimization. Here I am using only implication, so that is optimization 1, this NNF optimization 3, and then auxiliary variable only for entry is optimization 2, and then this creating equisatisfiable clause is basically the normal transformation, and then you combine these clauses, right. So, this is the actual steps of Tseitin transformation. So, with this I will conclude today's class. Thank you.